Hello guys, welcome back to another video. How are we today? Today our topic is about radiation biology for physical scientists, radiation interaction, physical and chemical events. In physics, radiation is energy propagated through space or matter as electromagnetic waves or moving subatomic particles. Exposing cells to radiation leads to expressions of biological damage through a chain of physical and chemical events. Energy deposition in biological materials. The energy from radiation needs to be deposited into the cell of biological material before it can produce a biological effect. Charged particle radiation, such as alpha particles, electrons, and protons, directly transfer their energy to other charged particles in cell through Coulomb interaction. However, in charged radiation such as X-rays, gamma rays, and neutrons cannot directly transfer their energy. Instead, they indirectly transfer all photoelectric effects or a portion of their energy. Compton effects to charge particles in the cells, and these charged particles transfer their energy to the biological material through Coulomb interaction. The units for the energy deposited is joules per kilogram, which is given a special name of Gray in honor of English scientist Louis Harold Gray. Excitation and ionization. The energy deposition can lead to different events that are dependent on the amount of energy absorbed by the cell. One type of event is called excitation, where the orbital electrons of atoms in the cell get enough energy to make an atomic transit from the ground states to a higher energy level without leaving the atom. This type of event will not be the focus on this book. The second type of event is called ionization, which happens when one or more orbital electrons from an atom in the cell has enough energy to leave the atom, leading to ion pairs. Ionization radiation can be further reclassified as directly ionizing and indirectly ionizing depending on the source of the energy. Ionization density. Ionization from radiation in biological material leads to a random and uneven distribution of deposited energy in cell. The spatial distribution of the energy imparted by the charged particle is quantified by the linear energy transfer LET, L linear, E energy, T transfer metric. It is the quotient of the average energy imparted and the distance traversed by the radiation with units of keV. Radiation can be classified into low LET or high LET radiation based on their LET value. The demarcation value between low and high LET is about 10 keV. Direct and indirect action. Cell contain organic compounds, protein, carbohydrates, nucleic acid, and lipids, as well as inorganic compounds, minerals dissolved or suspended in water. The critical target within the cell for damage from radiation is DNA. However, damage to other sites in the cell might lead to cell death. The biological effects of radiation can be classified based on the atoms or or molecules in the cell that are ionized by the radiation. Direct action of radiation refers to the ionization of critical target atoms of or molecules in the cell such as DNA. Indirect actions refer to the ionization of atoms or molecules in a cell other than target atoms and molecules in biological material.